Topic 2 began with all the ways you could factor. And now we're going to apply some of those ways to solving quadratics. So you can see this little diagram here on the first slide in Class Kick, which shows all the ways to solve a quadratic equation. So some of the ways we're going to touch on right now are solving by factoring, and you can see the word most common there in quadratic formula. We're also going to solve by taking the square root. We will eventually solve by graphing, but we will not be solving by completing the square. So that's one method that I do not teach you, and it's fine. You have plenty, as you can see, of other methods. One of the prerequisites for solving by square rooting is recalling how you simplify a square root that is not a perfect square. So we talked about perfect squares when we practiced the difference of perfect squares factoring. All right, so if you square root a perfect square, you get the original factor. So 5 times 5 is 25, so the square root of 25 is 5. But what about if it wasn't a perfect square, say the square root of 24? How then do we break down this radical and simplify it? Because when we're going to solve a quadratic by square rooting, we are going to simplify the square root. We are not going to type it into the square root portion of your calculator and turn it into a decimal. So we're going to want to keep our answers as exact. As soon as you turn a square root into a decimal, then you have to determine where to cut off that decimal or where to round, and it is no longer the exact answer, but an approximate answer. Okay, so square root of 24. This is the way I recommend you doing it, the most efficient way. So maybe make yourself a list of perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, and you can generate them on your calculator too. So you're going to take the number under the radical, and you're going to search for the largest perfect square that divides into that number. So if I look at 24 and I scan down the list, I see that 4 is the largest perfect square that divides into 24. And so we are going to factor that radical into the square root of 4 times the square root of 6, or square root of 4 times 6. Okay, hold on. I don't know what that's doing there. Sorry, cut and paste from somewhere else. Now, according to rules with square roots, when you have the square root of a product, you may separate it into the square root of the individual factors. So you may rewrite the square root of 4 times 6 as the square root of 4 times the square root of 6. Then, because 4 is a perfect square, we are able to simplify root 4 into 2, multiplying by root 6 remaining. And that is the simplest way to break down, or we say reduce, a square root. So let's take another number. Let's do the square root of 72. For the square root of 72, I would recommend that we look for the largest perfect square that divides into 72. And as you scan down those perfect squares, you are going to find some perfect squares that divide into it. For example, 4 divides into 72. But as you keep scanning down, 9 is a factor of 72. And if you keep going down, 36 is a factor of 72. And so the square root of 72 should be factored into the square root of 36 times 2. This is the most efficient way to do it, and it saves you steps and time. Then you separate them as their individual square roots. whoops, that would be a 2. And then you simplify the perfect square. So the square root of 36 is 6 with root 2 left inside. And that is simplifying a square root. And we're going to utilize that today when we're solving. All right, so let's talk about the methods for solving quadratics. And we are talking about quadratics of the form, and you can see there, ax squared plus bx plus c equals 0. And quadratics could have one solution, two solutions, or no real solutions. The non-real we're going to talk about after we practice graphing quadratics and finding their solutions that way. So we'll talk about non-real solutions down the road. Okay, let's talk about solving by factoring. So we're going to utilize the factoring techniques that we worked on the last few days. So first you want to get your quadratic into standard form, all right? Standard form is this form I highlighted in yellow, where all of the terms are on one side and it is equal to 0. So that means this is going to become x squared. We're going to add the 5x to the other side. We're going to add the 6 to the other side and set it equal to 0. We're going to factor the quadratic. Notice the lead coefficient there is 1. And so we simply factor using our pattern where two numbers multiply to be 6 and add to be 5. So that's going to be plus 2 plus 3. Notice that the only thing different between solving and factoring is that we now have an equals 0 at the end. This would indicate that we are solving because it is an equation. We use something called the zero product property, and the zero product property says if A times B, so I'm just going to write it here, if A multiplied by B equals 0, then either A equals 0 or B equals 0. And so if we utilize that property on our factored quadratic, either x plus 2 equals 0 or x plus 3 equals 0. Now to solve, we're solving a simple linear equation. Subtract 2 from both sides, x equals negative 2. Subtract 3 from both sides, x equals negative 3. You did this in topic 1.6 when you were solving nonlinear systems. But I'm reviewing it again, solving quadratics by factoring. All right, let's solve quadratics by square rooting. If the quadratic equation involves a square, so a square meaning x squared, and a constant, meaning we do not have the bx term. So when we say if it involves a square, that means it has ax squared and it has c, right? But it has no bx. Position the square on one side with the constant term on the other side. Then take the square root of both sides. If you have a negative number under the square root, this will lead to complex solutions or non-real solutions. We're going to pick that up later on in this topic. So we'll start with the first one. X squared minus 16 equals 0. So position the x squared on one side and the number term on the other side. Then we take the square root of both sides. So we're going to take the square root of x squared, and we're going to take the square root of 16. The square root of x squared is x. The square root of 16 is plus or minus 4. So when we are solving by square root, we need to remember the plus or minus. So I'm going to put a yellow circle around that because that is something important to remember. Here is a way to know for sure that both solutions are plus or minus, or that the solutions. I could also solve that quadratic by factoring. So I could take that quadratic and solve it by factoring, right? It is the pattern difference of squares. So that's going to factor into x minus 4, x plus 4 equals 0. Using the zero product property, x minus 4 equals 0, x plus 4 equals 0. That's going to give me x equals 4 or negative 4, which is exactly what I got when I solved by square rooting. Another type of solving by square rooting looks a little different over here. But again, it says to position the square term on one side with the constant on the other. What's different here is the square term is actually an expression squared. So I'm going to position the number term on the other side. I'll start by adding 14 to both sides. And then I will divide by 2. So I'm left with x plus 3 squared equals 7. Notice I have positioned the square term. In this case, it's not a term, it's an expression. It is the quantity x plus 3 squared. We're still going to follow the same steps. We're going to square root both sides. So that's going to be the square root of x plus 3 squared equals plus or minus the square root of 7. And again, I encourage you, that plus or minus needs to be a part of the process. So begin each time by saying to yourself, plus or minus, or go back and review these notes. So on the left, I'm left with x plus 3, because when you square root a quantity squared, you just get the expression or the term. And I still have plus or minus root 7. To finish it up, we're going to subtract 3 from both sides. Now 3 is, or when you subtract it, negative 3 is not a like term with root 7. And so it's going to look like this, negative 3 plus or minus root 7. Those are not like terms. I cannot combine them together. One of them is an integer and the other one is a radical. And so your solutions are irrational. This is called an irrational solution. One of them is negative 3 plus root 7. The other one is negative 3 minus root 7. You can leave it as I did in the first instance with the plus or minus, or you can write them separately. What do I mean by an irrational number? If you were to input negative 3 plus root 7 into your calculator, you would get a decimal. And that decimal is classified as an irrational number because it is non-repeating. So it's a non-repeating decimal, and it is a non-ending. Sort of like pi. Pi is an irrational number. It is non-repeating, and it never ends. Okay, let's move over to slide 3 and do some practice now, all right? Strategies for the most efficient way to solve a quadratic. So I put some steps down here to, again, like the flow chart for factoring, there's a flow chart for solving. What's the most efficient way to solve? GCF, does it factor? Does it have a variable that's a square term? If it doesn't factor, then you have to use the quadratic formula. So let's look at example 1. The first thing you're going to want to do is get your quadratic into standard form. So just to remind you what standard form is, ax squared plus bx plus c equals 0. This is not in standard form, so we're going to go ahead and put it into standard form. So x squared minus 3x minus 28 equals 0. Now we're going to factor that. So our pattern, we're looking for two numbers whose product is a negative 28 and whose sum is a negative 3. And so that's going to be x subtract 7, x plus 4. If you multiply them, you get a negative 28. If you add them, you get a negative 3. Now we're going to use the zero product property. So x minus 7 equals 0, or x plus 4 equals 0. Add 7, x equals 7, subtract 4, x equals negative 4. And those are my solutions to the quadratic. X equals 7 or x equals negative 4. All right, number 2. For number 2, again, we need to get our quadratic into standard form. So 3x squared, we're going to subtract the 7x, and we're going to add the 3. So taking those two terms from the other side and adding them, we're going to get 3x squared minus 10x plus 3 equals 0. Now, we have to see if it factors. And instead of using the previous factoring, because a is now 3, we need to either use guess and check or split the middle. So I'm going to demonstrate split the middle to keep demonstrating that guess and check is just whether or not you want to have the patience and you have the mental math to do it. So for split the middle, we're now looking for a product of 9 and a sum of negative 10. So your product would be multiplying A times C, and your sum would be B. And you're going to split the middle term into what you get. So product of positive 9, so I think we need to do negative 1 and negative 9. So 3x squared minus 9x minus 1x plus 3 equals 0. So now you saw me split, so take note. Here is the middle term. Here is this term and this term. Negative 1 and negative 9 add up to negative 10. So all I did was take that middle term and split it. Now I do factor by grouping. So 3x squared minus 9x plus negative 1x plus 3 equals 0. So I take that minus 1 and I change it into plus a negative 1. GCF, 3x, x minus 3, and sometimes the only GCF is a 1 or a negative 1. If it is a 1 or a negative 1, you should always choose the negative 1. So minus 1, leaving me with x minus 3. And what is not a coincidence is that this binomial is exactly the same as that binomial. If it isn't, you cannot complete factor by grouping. Since they are, we're going to get 3x minus 1, x minus 3 equals 0. So that x minus 3 becomes its own GCF. Now, zero product property, 3x minus 1 equals 0, x minus 3 equals 0, 3x equals 1, x equals 1/3, and x equals 3. And that is solving by factoring using split the middle. All right, number 3. Now, if you look at number 3, you've got two choices there because you do have a single squared term, right? 25x squared. You have a single squared term and you have a constant term. So your bx term is not in this polynomial or this binomial. You can therefore make the choice of solving by square rooting or look to see if they are special types of numbers. So in this case, they are both perfect squares. So you have the choice here. I'm going to do solving by difference of perfect squares. So I'm going to factor this into 5x minus 4, 5x plus 4. So difference of perfect squares factoring. Then I'm going to use the zero product property. 5x minus 4 equals 0. 5x plus 4 equals 0. 5x equals 4. X equals 4 over 5. 5x equals negative 4. X equals negative 4 over 5. What if you had chosen to do solving by square rooting? So I'm going to put a big OR. If you're going to choose solving by square rooting, it would look like this. 25x squared minus 16 equals 0. You're going to leave the square term on one side and put the constant term on the other side. You're going to isolate the x squared. So we do have to divide by the number in front of x squared before we square root. So x squared equals 16 over 25. And then we're going to square root both sides. So square root of x squared equals plus or minus the square root of 16 over 25. Now we already know that there's two answers. So if you fail to remember this when you're solving by square rooting, you will always miss out on one of the solutions. So x equals plus or minus 4 over 5. How do you simplify the square root of 16 over 25? That's the square root of 16 over the square root of 25. Just like we did with the product, where if you have the square root of the product, you can separate it. If you have the square root of the quotient or the square root of a fraction, you can separate it into the square root of the numerator over the square root of the denominator. Okay, number 4. Now, number 4, we have two terms again, right? And we see we have an x squared, but 3 and 12 are not perfect squares. So how might we proceed? Well, again, you could go back to the top where it says, is there a GCF? And there is. There's a GCF of 3, leaving me with x squared minus 4 equals 0. And from this point on, you can decide, am I going to solve by square rooting, right? Or am I going to solve by difference of squares? So if I use difference of squares, it's going to become x minus 2, x plus 2. That 3 does not get set equal to 0. That doesn't even make sense. So when you're using the zero product property, if there was an x out front, then you would set it equal to 0. But 3 doesn't equal 0, so basically you can ignore it. X minus 2 equals 0. X plus 2 equals 0, x equals 2, x equals negative 2. What if you wanted to do it solving by square rooting? And I present both methods because it's up to you to choose. So 3x squared minus 12 equals 0, 3x squared equals 12, x squared equals 4, so I'm isolating. And now I'm square rooting. So x is plus or minus the square root of 4, which is your plus or minus 2, which is exactly what we got when we solved by difference of squares. All right, let's look at our next page, more factoring. All right, number 5 presents to us in an odd way because it's set up as a proportion. What do? Well, we have to go back to prior knowledge. When we're solving a proportion, we cross product in the proportion. So that's going to give us 4x squared equals 24x. Now, this is going to be a binomial. So when we put it in standard form, 4x squared minus 24x equals 0, we see that we don't have a c term. We have an ax squared minus bx. So we're not going to factor by square rooting because that only happens when you have a squared term and a constant term. We're not going to factor by trinomials because this isn't a trinomial. So if you go back to the top of that list, we're going to factor by GCF. The GCF is 4x. What's left is x subtract 6. So remember, when you factor out the GCF, it's like reverse distributing. So think about 4x squared divided by 4x, leaving me with x. 24x divided by 4x, leaving me with 0. Now for the zero product property, we will set 4x equal to 0 because you can get a solution out of that because it's not 4 equals 0, it's 4x. And we will set x minus 6 equal to 0. X equals 0, x equals 6. So 2 solutions to that one. And we did it a little differently. Let's see if I can get my word or in there. O-R. Okay, number 6. Number 6 is a polynomial, and there's a bunch of terms there, right? Not in standard form. So let's get it in standard form. But also, I see a negative in front of the x squared, which I'm not a fan of solving when there's a negative in front of the x squared. So I'm going to put that to the other side. I'm actually going to move everything to the right side, okay? So that's going to be 0 equals positive x squared. So I'm moving that to the other side. I'm adding 3 to the other side. That's plus 8x. I'm adding 6 to the other side. That's minus 2. So I added the x squared to the other side. I added 3x to 5x. That's 8x. I added 6 to negative 8. And that's negative 2. It's a trinomial. I'm going to attempt to see if I can factor. So that would mean I'm looking for two numbers that multiply to be negative 2 and add to be 8. So 1 times 2 is 2. 1 times negative 2 is negative 2. There's no way I'm going to get an addition to be 8. So if it doesn't factor and it's a trinomial, then we need to use the quadratic formula. Okay, so let's go back to the first slide and let's review the quadratic formula. So that's number 3. All right, so solving by the quadratic formula means that we will use the quadratic formula to determine the solutions. The quadratic formula is right here. It is obviously not something you have to have memorized, but you do have to have access to it. When you look at your quadratic equation in standard form, you can see that A, B, and C represent the numbers of the quadratic in standard form, and those are the values that are inserted into the quadratic formula. All right, so let's do an example. If we end up with a negative under the square root, that is a non-real solution, and we will study that later on in the topic. So in our quadratic equation here, we see that it is already in standard form. It is already equal to 0. And so we can go ahead and establish what A, B, and C are. So A is the number 1, B is the number 6, and C is negative 11. We're now going to take those values and substitute them into the quadratic formula there. So x equals the opposite of B. Now we just wrote down that B was 6, so this will be the opposite of 6. And then you see a plus or minus symbol. The square root of B squared. Whatever the B value is, place it in parentheses when you square it. No matter what the B value is, place it in parentheses. Minus 4 multiplied by the A value and then multiplied by the C value. And then you see a long fraction bar because it covers the entire numerator, 2 times A. Now, to simplify, we're going to go to what's inside the square root and simplify our 6 squared minus 4 times 1 times negative 11. I would suggest you use a calculator. It's super easy. If not, it's going to be 36 minus a negative 44. Remember order of operations. You have to do the multiplying before you do the subtracting, right? So 4 times 1 times negative 11 is negative 44. We're going to then change it into add. So 36 and 44 is 80. So this now becomes x equals the opposite of 6 plus or minus the square root of 80 over 2. And as we did on that first slide, we have to simplify the square root of 80. So we have a little sidebar again. What's the square root of 80? Well, we consider our perfect squares, 1, 4, 9, 16, 25, 36, and we're looking for the largest perfect square that divides into 80, because we know that 4 does. 20 times 4 is 80, but we also know that 16 does. So we can write this as the square root of 16 multiplied by 5. Then we separate that, square root of 16, square root of 5, and we simplify 4 square root of 5. So within the structure of the quadratic formula, there are some separate sidebar steps that you need to do as you are working through. All right, so let's go back to our process. So x equals negative 6 plus or minus 4 square root 5 over 2. The next thing we're going to do is we separate. So this and this get separated. So negative 6 over 2 plus or minus 4 root 5 over 2. This is critical, this last step of simplifying. Negative 6 over 2 is 3. 4 divides 2. They're both outside the radical. 2. So our two solutions are x equals 3 plus 2 square root 5, or x equals 3 minus 2 square root 5. Or you can leave it as the plus or minus symbol. And that is solving with the quadratic formula. So now let's go back and revisit number 6 and use our quadratic formula. So we're going to establish our A, our B, and our C. So A is 1, B is 8, C is negative 2. All right, we're going to dump that into the quadratic formula. So x is the opposite of b plus or minus the square root of b squared. Notice me putting 8 in parentheses, minus 4 times 1 times negative 2. Notice the use of parentheses when I'm writing minus 4ac. Notice I bring that division bar all the way back because everything is above it. 2 times 1. Now we're going to simplify 8 squared minus 4 times 1 times negative 2. And again, use your calculator if you want. It's going to be 64 subtract a negative 8, which leaves us with a positive 72. If you are concerned about your mental math there, please take a moment to verify it in your calculator. Square root of 72, here comes your sidebar for that. We're looking for the largest perfect square that divides into 72, right? And so 4 does, 9 does, but so does 36. And so be careful with that. Always shoot for the largest perfect square because it gives you the most efficient way to simplify. All right, so this is going to be x equals negative 8 plus or minus, oh, no, sorry. So square root of 36, square root of 2, 6 root 2. 6 root 2 over 2. All right, then it becomes x equals negative 8 over 2 plus or minus 6 root 2 over 2. And so our final answer is x equals negative 4 plus or minus 3 root 2. And there are your two solutions. So please, this part here is super important. Remembering that one of your last steps is to separate them. I call it the butterfly. So it's like butterfly wings. Okay, number 7. Now, remember the first thing you got to do is establish what type of method you're going to do to simplify. And so when you're looking at number 7, you should check to see, is there a GCF, or can I factor by difference of squares, or can I factor because it's a trinomial? And then if not, you can go to the quadratic formula. So for here, if we were to factor regular trinomial, we would be looking for a product of A times C. So we would be looking for a product of 5 and a sum of negative 7. And as we know, that is impossible. And so we jump to the quad formula. So A is 5, B is negative 7, C is 1. And so that's going to be x equals the opposite of negative 7. That's going to give us positive 7. Plus or minus the square root of, and again, parentheses around B. And this is really important because you're squaring a negative. And if you don't use the parentheses, the result will not be correct. So b squared minus 4 times 5 times 1 all over 2 times 5. So opposite of b, plus or minus the square root, b squared minus 4ac all over 2a. So it's going to be 7 plus or minus the square root of, all right, so let's do the math. 49 minus 20 is 29 over 10. 29 is a prime number, and therefore that's your answer. Okay, number 8. For number 8, I'm going to let you try it on your own, right? And then go ahead and pause your video, and then go ahead and start it again and see if you got it right. All right, now as the case was with number 7, 21 is prime, so you can leave your answer like that. I do want to go back and make a note that for number 7, you can also write your answer as 7 over 10 plus or minus root 29 over 10, and this one is negative 1 over 2 plus or minus root 21 over 2.